let's do some practice with this A. So here we have our quotient rule. We have the same base on the top and the bottom, so we subtract the exponents. So we take the top 3 minus the bottom 3. That gives us v to the 0, which is just 1. The top and the bottom essentially divide each other out into 1. Number 4, we've got 2/3, which when looking at these values, try to simplify them, but 2/3, you can't simplify that at all. But then we have a battle right here with the x's. We've got x to the 1 on the bottom and x to the 3rd on the top. So the rule says it will be x to the top exponent minus the bottom exponent, which is x squared. And that goes on top. Or you could say to yourself, well, I have 3 x's on the top, 1 x on the bottom. These x's factors cancel each other out, so I have x times x on the top, which is x squared. Or you could say there's 2 more x's on the top than on the bottom, so x to the 2nd power on the top. Lots of ways to think about that. Number 6, before we worry about the battle or who's going to win this with the ends, because I notice there's ends on the top and the bottom, let's simplify the top. So I'm going to pull this coefficient of 2 out in front, and then I notice that I have n squared times n to the 3rd. We add the exponents there. It's n to the 5th, 2n to the 5th, divided by 3n. Again, 2/3 I can't simplify, so I'll have a 2 on the top and a 3 on the bottom. But now I have n to the 5th divided by n to the 1. So who wins that battle? Are there more n's being multiplied on the top or on the bottom? There's more on top. By how many? 4. So there's our final answer. Number 8, simplify the top and the bottom before you worry about battling. So I have 4k to the 3rd on top. I can't simplify that. But on the bottom, I have k times k times k times k times k. There's 5 k's getting multiplied together, so that's k to the 5th. So here, I have 4 divided by 1, which is 4, so there's a 4 on top. And then I have a battle here with the k's. So the bottom's going to win it because there's more k's being multiplied together on the bottom. How many more? 2 more. So k squared goes on the bottom. If you chose the subtraction method, it would be the top exponent minus the bottom exponent. 3 minus 5 is -2. So that needs to go on the bottom and make the exponent positive. Excuse me. Number 10. So we want to simplify this, but realize that we have a negative exponent right here. So that's like a traitor. We have a negative exponent right here. So on top, we have 4 times 3 times m to the 3rd times m to the 3rd, and then we have this m to the positive 1 that moves up to the top. And when we move it, we make the exponent positive then. On the bottom, we have a 3, and we have an m to the positive 4. That's from this negative exponent that moved out of the bottom, and the exponent becomes positive. We still have some cleanup we can do here. On the top, 4 times 3 is 12. And here we are multiplying the same bases together on the top, so we add the exponents, m to the 7. On the bottom, we have 3m to the 4th. So let's simplify the numbers. I have 12 divided by 3, that's 4. By the way, if you were thinking, well, Mr. P up here, aren't these common factors here on the top and bottom? Couldn't I just kind of reduce that, cancel them out, and make it 4? Yeah, that's true. That's totally correct. There's not exactly one way to do things. There is a process that is advised or suggested. There are some times where you can go your own way, and still it's mathematically correct and you get the right answer. So that's reducing or simplifying 12 divided by 3. That's the same as 4. Now we have this battle. who wins the battle? Because I have m's on the top and m's on the bottom. The top's going to win because there's 7 of them and only 4 of these. So the top gets the m. How many more are there on top? 3. So I guess we don't even need a fraction here. We could put a 1 underneath there, but it's the most simple answer is going to be 4m to the third. Whoa. 4m to the third. Boom. Let's go to the back. The back gets really fun. All right, let's simplify this stuff. So I've got a traitor there, or a negative exponent that's sitting on the top, but it really belongs on the bottom. And I have a negative exponent here sitting on the bottom that really belongs on the top. So let's switch that up. So on the top, I do have a 2. This is going away, but I have an r to the positive 1 that goes from the bottom to the top. On the bottom, I have a 4, r to the 4th times 3. Remember, this negative exponent just goes with the base. The base is r, just like right here. So that 3 stays, and then I have r to the power of 2 on the bottom. I moved this guy to the bottom, kept the exponent positive, or made the exponent positive. So now let's simplify the bottom. There's a lot of simplifying we can do. 4 times 3 is 12, and then we have r to the 4th times r to the 2nd, which is r to the 6th. Simplifying the numbers, 2 divided by 12 is 1/6. 1/6. I made a dash because if there's anything else left up there, I don't need the 1. But if there's nothing up there, I need the 1. And actually, it looks like we'll have nothing up there because now the only thing that's left is this battle with our r's. The r's on the bottom win because there's 6 of them compared to 1 on the top. So there's 5 left over, 5 on the bottom. So final answer, 1 divided by 6r to the 5th. All right, let's do some sprinkling. I've been missing sprinkling. So we raise 2 to the 2nd power. We raise m to the negative 2 to the 2nd power. And everything down here also gets raised to the 2nd power. So let's sprinkle or disperse that power of 2. So 2 squared is 4. Multiply our exponents here. That's m to the negative 4. On the bottom, 2 squared is 4. And then we have m to the 8. We've got a traitor right here. That needs to move to the bottom. So we have 4 divided by 4m to the 8th, m to the 4th. So now we'll simplify the top and simplify the bottom. The top is just 4. The bottom is 4m to the 12th. All right. So now we can simplify the values or numbers on the top and bottom. 4 divided by 4 is just 1. The m to the 12th on the bottom doesn't get challenged at all on the top. So the m to the 12th stays on the bottom, and there's a 1 on top. Final answer. Ooh, look at this sprinkling. Sprinkle, sprinkle. And by the way, maybe we should, hopefully you're kind of looking at your notes. If you're wondering if Mr. Pischke's just going rogue and just choosing what to do based on, what seems fun. Remember on page 17 of your notes. This is page 18, by the way. If you kind of remember just the basics of do I add or multiply or sprinkle, there we have that. But on page 17, you've got this process, which is handy to have out, especially now because these are starting to get tough. Holy cow. So, sprinkling. And that's all the sprinkling we have. That's too bad. So x to the negative 2 times negative 2 is x to the 4. Hey, do you remember what y to the 0 is? It's just 1. Anything raised to the 0th power is 1. So I'm not going to even write it down because x to the 4th times 1 is still just x to the 4th. So then I have times x to the 4th times y to the 3rd out here. On the bottom, I've got this traitor right there. So this thing right here, let me put it in green. This thing right here actually belongs on the top as well. So I've used the 0 rule. I've sprinkled. That's using the power to a power rule. Now I'm looking for negative exponents. That belongs on the top as x to the positive 1. And y to the 0, oh, I had a y to the 0 down there. That's 1. Now, if we just have a 1 on the bottom, we actually don't even need to write the bottom anymore. So let's clean up the top. I've got 3 sets of x's that are getting multiplied together, 4 of them here, 4 of them there, and 1 of them there. All in all, that's x to the 9 and y to the 3rd. And again, it's divided by 1, but we don't need to write that down. There we are. Let's try. Let's try number 20. Sprinkle, sprinkle. I don't see any 0 exponents. Skip that. So don't see that. Now I'm using the power rule. So I'm sprinkling this power of -4 to everything inside of the parentheses. I'll copy down everything else that we have here. So we've got 2x to the 4th, y to the -2, times x to the 16, y to the 12. Check. Remember, negative times the negative is a positive. On the bottom, we've got x times y to the -3. So I've applied the power rule. Now we identify our traders, our negative exponents. I got one right there and one right there. So let's move those. So on the top, most things don't move. I've got 2x to the 4th, x to the 16, y to the 12. I didn't write this down because it's moving. On the top, I also get this thing from the bottom, this y to the what's now a +3. On the bottom, I had an x. This y to the -3 moved up to the top, but this y to the -2 on the top moved down to the bottom, and its exponent becomes positive. Alrighty. Now we have some simplifying to do. I like to clean up the top and the bottom separately. So like on the top, I've got, let's see, x to the 4th times x to the 16 is x to the 20, and y to the 15. On the bottom, there's no simplifying that we can actually do. So we've just done the product rule, simplifying the top and the bottom. Now here, we have the quotient rule, where we have these same bases that are on opposite sides of the fraction bar, so we have some battles. So that's x to the 20 divided by x to the 1. The top wins, so x is going to stay on the top, and it wins by 19. Subtract your exponents. Here the y's are going to win. 15 minus, the y's on the top are going to win. So y goes to the top. How many more of them are there up there? 13. So 2x to the 19 times y to the 13 is your final answer.